Thank you for joining me on this question. We're looking at a question which has like compound interest question, and it says an amount of $100,000 is invested, and that's the amount invested, and its annual rate is 6.25% per annum, and the interest rate is calculated yearly. How many years will it take before it reaches, now I'm going to change this to principal, and I'll call this the amount that is finished up with is $150,000. Well, we've looked at this compound interest formula. It's principal times 1 plus, you probably have the formula R over 100 to the power of n. So our A value is, it becomes 150,000. It started out as 100,000, and it's 1 plus 6.25% per year, and how many years. So we've got, we could take 150,000, we could divide that 100,000, and we're left with this is 0.0625 to the power of n. And this becomes 1.5. Is 1.0625 to the power of n. Now what we could do here is take the log of both sides. So if we take, or just turn it into log notation, because this is index notation, and we could turn it into log notation just by moving a few things around and saying that the log of the number 1.5 to base 1.0625 equals n. So there's the log notation. And this, there is a log law that says the log of a to base b is the log of a over the log of b to any base that you want, in fact. I'm going to use base 10 so that we can say on the left hand side the log of 1.5 to base 10, so we don't put a 10 there because it's a common log, over the log of 1.00625 is equal to the number of years. So let's put that in the calculator. You're going to have to trust me on this one because I've got the calculator on a separate device. It's actually on my iPhone, and I've got to turn the calculator on and rotate the phone so it becomes scientific. Now the log of 1.5, I'll just press log of base 10, is 0.17609 ... over, and the log of 1.0625 is about 0.026329 or 89 ... Now if I go back to the original numbers and just go into one calculation, the log of 1.5 divided by 0.0625, the log of 1.0, equals, and it is 6.688 years. So if it's annually, it would take 7 years to get over $150,000. Now the question did go on and say, what if it's monthly? Well, I'll leave that for another time, and I hope that this has helped. Until next time, stay happy.